Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. So in today's lesson, we want to look at the continuation of finding derivatives of trigonometric inverse functions. So in previous lesson, we solved example 1 to 7. In this lesson, we want to look at example 8 and 9. So please, I urge that if you have not watched the previous lessons, please try to watch them, because it's going to help you to put your own path so that you don't get yourself, in between the roads when you are found around here. So question 8 says y equals to e raised to the power cos inverse. So I'm just going to use exponent now instead of radicals. 1 minus x squared raised to the power 1 over 2. So this is the derivative of tangent of cos inverse of x or cosine inverse of x. So we know that the derivative of e raised to the power x is just equals to e raised to the power x times the derivative of x. Now, so to find the derivative of y prime, we just rewrite this whole thing, e raised to the power cos inverse of 1 minus x squared raised to the power half times the derivative of this power. So how do we differentiate cos inverse of an angle? The rule said it's negative. Cos inverse is negative 1 all over the square root of 1 minus x squared. Now this angle represents our x, so it's 1 plus 1 minus x squared raised to the power 1 over 2 all squared. Now we have differentiated cos inverse. We must now differentiate the angle of cos inverse of, cos inverse of this angle. We must differentiate this angle as well. So the derivative of that angle now is just 1 over 2. We bring this power down. We rewrite the expression 1 minus x squared. We subtract 1 from the power, it becomes minus 1 over 2. Then we differentiate 1 minus x squared. So the derivative of x squared is just minus 2x. So this 2 can cancel this 2. So now we have y prime to be e raised to the power cos inverse of 1 minus x squared raised to the power 1 over 2. Now what we can do is that this 1 minus x squared is, the power is negative, so it goes down in the denominator to be positive. So we're going to have, just put it right behind this radical. So it's 1 all over 1 minus x squared raised to the power 1 over 2. And what do we observe here? Okay, so this is raised to the power 2, so this 2 can cancel this 2. So it's like we have 1 minus 1. Negative times this negative is positive. So this 1 will cancel this 1. You just be left with the square root of x squared. And the square root of x squared will just give us x. So this whole thing now will just be positive x. Now we know in the numerator here we also have x. This x. So this x can cancel this x as well. So what do we have? We can write our final answer as that was negative x. So negative times this negative will give us positive. So now we have y prime to be equals. So the x and this x go out. We will now have e raised to the power cos inverse of the square root of 1 minus x squared times, okay, so we just put it in the denominator. So we take the square root of this one as well, rewriting this exponent form now. So it's 1 minus x squared. So you can decide to say this numerator is just equal to y, whatever the case might be. So you could just write it as y all over the root of 1 minus x squared. It makes no difference because y is just equal to this expression. So let's look at the next problem. Okay, let's look at the next problem. I thought we were done with the problems. So question 9 says y equals to sine of tangent inverse of e raised to the power minus x. So y prime equals, now the derivative of sine of an angle, the derivative of sine of an angle x is just equals to cos of x times the derivative of x. So the derivative of cos of sine of this angle is cos of this particular angle, which is now tangent inverse of e raised to the power minus x, times the derivative of the angle. So the derivative of tangent inverse of an angle, this tangent inverse, is 1 all over 1 plus x squared. But this x represents the angle that is here. So the angle here now is e raised to the power minus x. So it's raised to the second power. Now we are not done. Say times the derivative of the angle. So the derivative of e raised to the power minus x is e raised to the power minus x times the derivative of minus x, which is just minus 1. So then we say we done. We just need to simplify the problem. So y prime now gives us, so this is negative. So if this comes on this side, we have minus cos of tangent inverse of e raised to the power minus x divided by, now we can rewrite this expression as the reciprocal of this so that this power can change to positive. So we can just bring it down, e raised to the power positive x. So we can also do the same for this. Remember, if we multiply power by power, this is going to give us minus 2x. So we can just rewrite this such that we will have 1 plus 1 all over e raised to the power 2x. We're just trying to simplify further. So this time, this one, so we have cos, negative cos of tangent inverse of e raised to the power minus x divided by, so it's e raised to the power 2x times 1 is e raised to the power 2x plus 1 all over e raised to the power 2x times e raised to the power x. So this e raised to the power x can cancel 1 from here. You'll be left with e raised to the power x. So because this e raised to the power x is in the denominator of this, it goes within the numerator of the expression. So we're going to have y prime to be minus, this e raised to the power x is going up. So it's e raised to the power x cos of tangent inverse of e raised to the power minus x, all divided by e raised to the power 2x plus 1. So we just try to simplify this further, and this is now our final answer. So thanks all so much for watching. See you in our next lecture. Thank you.